Thanks again for everyone to be here. It's very, very nice to be here, and thanks for having me. Now, you know explosives, once it's in your blood, it's hard to do anything else. I started off on the mining side at the chamber and then developed through shaped charges, and then ended up now for the last 2 decades demolishing buildings. So what I want to do today is just discuss a bit about demolishing in general. Some of it's by explosives, oftentimes it's not by explosives but other methods. Right, so why do we demolish things? It's quite simply because structures all have a finite life, and everything that's built must be broken down one day unless it stays as a national monument, and then you're doing lots of maintenance over time. Conventionally, over the years, it's been done by reverse construction. So if you build it bottom up, you take it away top down. And people will use cutting torches, jackhammers, small machines, cranes to lift things off, or else drop sheets to drop it. It's quite labor intensive. It's dangerous. You're working at heights, lots of that. There's high gravity hazards. It's slow, and it's also costly. Now, these pictures aren't the best. They were taken from the printed press, but it illustrates what can go wrong when you do reverse construction. You know this nice building in Rosebank where Standard Bank had that big building full of glass? Well, this was taken from an office worker next door. There's an excavator working here. It's only 3 stories high. This was that Audi dealership for cars. But this company wasn't suitable to do the work. In the first place, they hired a 5-ton machine. Sorry, only going forward. There we go. Sorry about that. So they hired a machine that's busy breaking, and it's a bit like sawing the limb of the tree off where you're sitting. But he was breaking, and this thing collapsed on top of the machine. See that floor there? There's this one here. It fell down, and it looks a bit comical, but this guy died. He was crushed, wife and 2 small kids, and he's dead as doornails. So it's really quite sad. Something very simple can go wrong, and this happens a lot in industry. People demolishing a building like this may be stripping out a window, the lintel fails, and someone dies. It actually happens often. This is another one from the press I took out several years ago, and you'll see this often in the developing world. People take down all sorts of buildings by hand. This was a silo in Zambia. And the interesting thing is here is these guys are mitigating their risks. You see the rebar as they're standing there? They take the outside bars, bend them out, the inside bars bending in, and they actually have a bit of a safety cage there to work in. But this is not the way you want to work. It's like looking at the slides from 100 years ago in the gold mines. The hazards are simply too much. So now the factors, if we look at how do we select the different methods, or select one of the methods to demolish a building. Some of the factors you have to look at is, of course, always safety. It must be done safely. You'll have to look at the time available and the cost of those methods, balance that against the project, how much time is there. Some projects are several billion rands. Once they say go, you need to take it away quickly. So you can justify a method which costs more, provided it's quicker. Other times, speed is not required, so they just want the cheapest way of doing it. Also, you have to consider, sorry, I'm hitting the wrong buttons here. You have to look at, do you have the right equipment to take it down mechanically? There's some very large equipment these days, so oftentimes you can do it mechanically without blasting. Also, how much space is available to do the work, and which method is most appropriate. And with all methods, you have to look at what's the potential to damage other buildings or services nearby. And if you look at buildings in general, for every sort of 400 you'll take down mechanically, one of those will be explosively done. Right? So most things are, in fact, done mechanically. So what are some of the advantages of using explosives? Safety, definitely, for the right addition, you can minimize the gravity hazards, and those, the two aspects of that, people falling from heights and materials falling from heights onto people. You can minimize the amount of man hours and their exposure to these hazards by getting this building onto the ground quickly. In those cases of large structures, it is cost effective, it's quick, especially for big, very large structures. You'll find that in some cases explosives are definitely supreme. If you look at a structure like this, which were some cooling towers in Cape Town, 90 meters high, several thousand cubes of concrete in a bad state of structural integrity. You prepare these quickly with explosives on the ground. It's the quickest and safest way and most cost effective of doing it. Here's another example. This was the Corex facility in Pretoria, the old ISCOR works. This one is 105 meters high. We demolished the rest of the structures here so there was space to drop it. So here again, you put several thousand tons of steel onto the ground where you can then disassemble it and take it away. In this case here, explosives are supremely superior to any other method. But not every building or structure is appropriate for explosives. This is a good example of one where mechanical methods are far better. This was the Allendale Bridge on the motorway between Joburg and Pretoria. We took away 3 of those bridges for that improvement project so everyone can pay e-tolls. And this bridge, we had 11 hours to take it away. So we had to start on the Saturday night. They diverted traffic, and we had to take it away and clean up so they could open again on the Sunday morning. So in this case, there's no time to prepare it for drilling. You would throw the steel and concrete around. It just wasn't appropriate. Where you can always use blasting, oftentimes it's not appropriate. So here, you do saturation work, you put machines all over this thing, and you take it down chop chop, and then clean it up, and then you go drinking. Here's another example where explosives are not only inappropriate, but they're prohibited. This is like at a petrochemical facility. They don't allow blasting for obvious reasons. It's just too dangerous. The other thing is here, this stack, which we're working on, there was no space to drop it. Previously, they had a stack twin to this one, which they took down by hand. It took 8 months to take this down. Look at all the risks associated with that. So what we did here is we brought in, I'm hitting the damn wrong buttons here, I apologize for that. We brought in a large crane. We have a hydraulic crusher here, which has then steel shears in the throat for the rebar, and then we hang it here at the top, and then bunch the thing down from the top. And we were able to do that in 7 days. There's a close-up there. You take your hoses up here at the back, and then it works quite effectively. So in this case, again, explosives are not appropriate. The other thing competing for the work is mechanical devices like this one here, which is a high-reach machine. This boom is telescopic. You can reach up to 12 stories with this machine. So oftentimes you can walk in, not have people working at heights. You stand back here, you munch this thing down, chew the concrete, cut the rebar, and there's the end. And debris there on the ground, so it's quite quick and also effective. This can also be done with steel structures. You start at the top, cut it away with a shear, drop it in pieces. In this case here, this structure behind was 1 meter away. So you can take it down, and there's the end results. That structure was sitting here, and we didn't cause any damage to the structure next to it. Now, important considerations when you're using explosives to demolish buildings. You know, earlier we heard about what's important, drilling, drilling, drilling. Well, here, it's safety, 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 right? If you're using explosives, there's lots of space to make a copy, right? We all know that. We like breaking things. Anyone using explosives loves to break things. But if you're looking at a large building and you've decided now to use explosives, the first thing you must feel is fear. If you're not afraid, you are a fool. So you start from fear, and then you work to engineer the thing, to design it, to mitigate your risks. But you must start. If you're not afraid, you are a fool. So you have to consider all of these factors: the fly, the concrete, and the steel. Sometimes you have to weaken the structure a bit. Other times you have to strengthen it. If you're weakening, you must be concerned about wind and seismic effects. That bump we had a few months ago, well, actually the earthquake there from Vol Roofs. I was sitting in our office on the second floor on the telephone, and my chair was going back and forth. And the first thing that came to mind was, what if we had a structure weakened for a blast? So you must always prepare for that. You have to guard against direct impact damage. If there's services in the ground or a building next door, if you moor into those, then you've got problems. You have to control or protect against dust. If you're in town dropping a building, there's lots of care you must take, covering up air conditioning vents and shutting them off and so forth. Vibration, both from the explosives themselves and also from the impact of the structure on the ground. Further, you have to worry about air blast. If you're not careful, you'll take out all the windows in the buildings around you. If it impacts the ground and there's any sort of excavation, you have to worry about the bulk movement of that ground, which can move and damage services and buildings. You have to look very carefully at the structural integrity of nearby structures. Sometimes these old buildings are busy falling down and they're full of cracks to begin with. So then you must look very careful indeed. Otherwise you will cause further damage. Disruption of services and activities, things like rerouting traffic on the motorway for a few hours, that's one issue. But if you damage main utilities and put people's services out of action, like electricity, water, sewage, you could be in very deep trouble. Now the methods of actually doing the blasting, are actually applying the explosives. You can drill holes in concrete, much like in rock. There you have to look at the steel rebar, sometimes steel members inside the concrete. The explosives that we would use in that case would normally be a water gel, because it's quite a robust explosive. It's much less sensitive to desensitization like the emulsions are. It's actually quite physically robust. We also use shaped charges for cutting of steel and breaking of concrete. Sometimes you'll attach also commercial explosives and cartridges to kick members out of the way. Initiation will use shock tube and electronic deads together with cord, depending on what the situation is with detonating cord. Here gives you an example of a shaped explosive charge. Basically, you have a high performance explosive around a cavity. And this can either be a linear charge in this case, or it can be conical. This is one of our charges called a saber jet. It's 1/2 meter long, weighs 200 grams, and you can cut through 1 inch of steel. So 25 mils, it actually severs it. Here's a conical charge. You can see this large roller at the steel mill was split in half. It was shot in here, and the force available split it in half. Here's a large section of steel, 250 mils here, 3 kg charge here, actually chops it in half. That charge, we call it a jet axe. Quite effective for very heavy steel members. This gives you an example of what you can do in extreme cases. This one here is over 1 meter, both ways here. Here we shot a hole in with shaped charges. There's the actual crater, and then we split it by charging this with explosives. So basically, there's anything you can tackle with this type of charge. These are charges that we developed here in South Africa. These charges don't have metal on the inside. So you actually have just a hollow. In this case here, this is a section through the charge. There's a body of explosive. There's a cavity here. You initiate it back here. The detonation front moves forward. The gases collapse into this cavity and give you a jetting action. That's why we call this charge a hammered jet. So it produces a hammer blow effect from the jetting action of the gas. It's quite effective. The only disadvantage there is air blast. And the interesting thing is I just heard this morning from Tony Rourke. He was in China not long ago, and they've actually copied our charges, and they're using them there in China. Now, the way of actually dropping the buildings, there's two basic ones. The one is implosion telescoping, and then the other one is toppling. So you can topple it as a rigid body. Otherwise, you weaken certain elements in the building and have it collapse as it comes down. And you can have all sorts of combinations of those as well. Sometimes you'll split the structure in pieces and drop it in different ways. Now, this gives you an example of a good reason for imploding. This was the north section of Minatoria in Pretoria several years ago. And this one was burnt out by fire. Several of the floors have actually come loose and collapsed. Lots of the other ones were hanging. And this was quite a job. We had to implode this and clean up in 3 months. So what we did here is first of all clean out all of the damaged internals. Because of all the soot and everything else, you can have quite a dust cloud that covers everything in soot if you're not careful. So we had to clean it up. And we had to implode it, pull it away from the building next door to it here, and then clean it up afterwards, which we did in a period of 3 months. Here's another one. This is quite a different one, a gas holder with the floating roof. This one burnt out, 68 meters high, next to the main plant power lines. There's a large gas line behind it as well. So what we did here is we used 232 charges, steel cutting charges, blasted out a smile, kicked it out, and then pulled this away from the surfaces. This is a combination of both explosive and mechanical methods in this one. This is the Lidmar Dam, and they built this dam wall initially have radial arm gates fitted between there. When it came time to raise the dam for more capacity, the retrofitting of those gates were too expensive, so they decided to demolish the top of this dam and then build it up. So what we had to do here was take away the bridge deck, the piers, and 1.8 meters of the top of the crest. So what we did here is we blasted using electronics, very small charges. We drilled on spacings of 300 mils apart. We had to produce a surface with a tolerance of 25 mils, and we weren't allowed to damage at all the concrete beneath us. So we used very small charges. We decked it with Cortex, and then we used electronics, so we had individual firing for each hole. We peeled it off very nicely. We cut this corner. We had to maintain this corner. You'll see it just now. And it worked quite well. So first of all, we blasted away the crest. Then we dropped the decks onto that crest in sequence. We took a machine apart in 3 pieces and reassembled it here on the dam wall. And then we walked across the top of the dam, demolishing the piers. And then after that, they built up the new dam wall. So it's a nice example of how you can end up using both explosive and mechanical methods. This one here was at Waterfontein factory, a very challenging one, where you had a prill tower 55 meters high. This is an explosive plant here, ammonium nitrate, 1.5 meters away. We are surrounded by services here, gas lines, steam lines, power lines. There's a substation. There's also service lines here. We dropped this thing on top of the main water supply and the 6.6 kV cable, so we covered that all up with ash. We put a catch fence there, and there's more steam lines here in the back. So this one, we were very afraid. If you look here, there's our heaps of ash which we put over those surfaces. We put up a catch fence here with some concrete blocks and then diamond mesh fencing. And to make sure that this thing fell precisely, we manufactured hinges. We installed them. We cut this out with diamond cutters. We installed them. We laser aligned them. We then braced up the bottom of this prill tower, and then we blasted away the concrete in front. And here at the back, we also diamond cut through. And And there's the end result. So it dropped on top of the services there. We contained the debris and decided we'll never do this one again. Stomach is not thick enough. Here's a chimney which we dropped using explosives, 90 meters high. In this case here, there was space to drop it. So you prepare it here on the bottom. You basically blast out a smile. You pass the center of gravity. Make sure that you define your hinge points first mechanically so that you don't disrupt the spine at the back. And this one, it's always a beautiful sight to see them fall. But what happens as they fall, if it's concrete, it'll fall as a rigid body. But this one, basically the top can't keep up with the bottom, and you'll see it always give in these brick ones because the angular velocity here at the top doesn't keep up with that at the bottom. Here's a set of 5 cooling towers. The one you can't see here at the back, but here we drop them in sequence. In this case here, you'll actually blast out the legs, also blast out a smile. You can see in this case they're falling away from us. And these we blasted a second apart, give them a chance to dissipate the effects of the air blast and the vibration. And there you can see the results afterwards. Again, this is a job for blasting and nothing else. Here's a case where there's some large steel bridges down in the top. And there the good old boy said, we'll cut this down with a torch. And it didn't work so well, this one slumped. There were people working this side. And they claimed the one guy cutting here ran over the top and down the other side and he disappeared. I'm not sure if that's true. But then we came in and what we did is we blasted them off between the piers, we dropped them down, and then they cut them up and took them away. Here's another bridge over the Oolifants River on one of the collieries. We blasted this one into 6 pieces. Out in that part of the world, no concern about air blast, you just let rip. We tied up wire rope here first, so once they fell there, we pulled them out, so we dropped it and pulled it out the same day. These were those towers in Cape Town. These supporting rings on this one fell down. It was declared unsafe. We had lots of drama with this one. We had the paperwork on this job was about a meter high. In the end, there was lots of services around. We had everyone busy, excuse the French, coughing off on this one. Everyone worried. We had the main sewer line for that area running right past the tower, 6 meters away. If we damaged that, we would back up sewerage into 3,800 homes within about 120 seconds. So it was a bit of a stressful one, that one. So what we did here is we dropped them towards each other. There you can see a bit of our protection. So we drilled 7,200 holes here. We then put our coverage here, geotextile fabric, diamond mesh fencing. We blasted this one first, then the other ones. And what you do is take out a smile here. You give these things no option. It's asymmetrical. Once you remove that, folds over, it hits, and then it folds much within the footprint of itself. And there it is, busy folding. There's the first one. This one was a second later. And everything else stayed here. There's the end result. We had our services running here. We had a gas line, power line, fiber optics. We had a big tunnel through here. We had the main sewer lines through there. There's a pumping station there, power station here, which still had transformers and cables and so forth. So that was also a nice one to get out of the way. It makes the beers taste very good, I must say. Now here's a good example where shaped charges come into play. This is our company logo. Our jet comes from the jetting action of the shaped explosive charge. There's the charge and there's the jet which it produces. In this case here, there were 20 silos. And what we did was put in a few anchors here to avoid the drilling. We then strung ropes. We hung our shaped charges, hooked up dead cord, and then you let fly in one go. Nice, beautiful fireball. There's a bit of coal around, so we had a nice afterburn. And then it lays it down very nicely onto the ground. So this was set up and fired one day. What we did after that is we dropped them 4 at once. So we would prepare it one day, blast the next. Very quick, very efficient, very safe way of doing it. Another one is water from tank, bulk store that has to stay. This one was touching it, so we had to rebuild the bottom of this because it was quite fraught from the fertilizer, and then blast it away and then drop it towards us. There it is going, pulling away from that structure. Here's another one, 250 meters long. This was the mill building at Western Holdings Gold Plant. The bins were empty, so we cut out 2 out of 3 legs, blasted it, toppled it over, and then you can climb in with machines to finish it up. Here's a rigid body Foley, headgear, very, very strong concrete. This one was quite simple, blast away the front and topple it over. This is one of those oh shits. This is the drag line working late, end of the month, Saturday night into Sunday morning, bucket hits the spoil and it falls. Now this one was doing the overburden, the one stripping the mid-burden was following behind it, so production was threatened. So it was pulling out the stops to get this off, to get this machine out of the pit, walk it out, so you could then come with the next drag line. There's the one which failed, there's the one coming behind it, so we didn't have much time. So we had to improvise, we didn't have time to make up the right charges here, because these cords are 40 mils thick, like strong steel, so we had to improvise. Fortunately, it worked, and there we chopped it off there, so they could then walk it out of the pit. Now, once things are on the ground, you can then climb in with machines, do the secondary breaking up, hydraulic hammers, crushers and shears. There's another grapple. And here's a large machine which will handle just about anything. This is 80 tons. This shear weighs 15 tons. And anything that fits in there, you can break. I see I'm over time, so I won't be showing any videos now. But thank you for your attention. If anyone wants to see videos later, I'll be happy to show them after the discussion. Thank you.
Thank you, Jeff.